Hello and welcome to this episode of T-Tech. This is part 1 of 3 in our series to configure FreeBSD as a firewall. Now, here we're going to talk a little bit about the concepts and how our network is going to look. So, our layout will be like this. We're going to have an ISP up here, our internet service provider, and we're going to lease a link to the internet connection. And that is going to come in to the WAN side, the wide area network side of our FreeBSD machine, and that will be our internet connection. Now, we either have a cable modem there, a DSL, a satellite modem, fiber modem, any of them. So that is our WAN side, regardless. Now, what we want is we want to have a private side. And that's what our LAN side is, the local area network. And this side is off of the other interface of the FreeBSD firewall. So there's two interfaces, one for our WAN and one for our LAN. Essentially, it allows traffic out from the LAN to the internet, but it doesn't allow any responses that we're not expecting, any traffic, in other words, to come back from the WAN. It's going to just drop it. So every time the LAN sends, it's going to keep state, and that way when it comes back from the WAN, if it's in the state table, it will let it back through. And essentially though, if PC 2 and 1 here want to communicate, they can just go right through the switch locally because they are on the same network. They're on the same LAN. But if we want to talk, if PC 2 wants to talk to Google.com, then we have to get the firewall involved. And as well, before we go on to how the packets flow and everything, something to address. When I say firewall in the series, I am actually basically referring to firewall and router. Now they do have two separate distinct functions, but in this case there's overlap between the routing functions and the firewalling functions. What I mean by that is they're done by the same machine. So when I say firewall, I mean router. Alright, so we'll move on and look at how packets are flowing. So PC2, if he wants to send a packet out to the internet, he first needs to know the firewall's MAC address of its IP address, of its LAN IP address. It's got to find the MAC address. To do that, he sends a ARP request packet out through the switch, and the switch is going to flood that, and then the FreeBSD machine is going to see it and realize it's for him, and he will send that reply back down to PC2 with his MAC address in it. So PC2 will then take that information and put it into its ARP cache. Now though, when he wants to send a packet out, he's going to send a packet with the source 192.168.1.3 at layer 3. So his IP address, that will be the source. The destination IP address will be Google.com's IP address. So he got that over DNS before this happened. And now he sends it up to the switch. At layer 2 though, the source MAC address is PC2, and the destination MAC address is FreeBSD's Ethernet interface. So he'll send that up. And then once it gets through the switch to FreeBSD's interface, then FreeBSD can start to process that packet. Okay. After it gets there, there is something it has to do called NAT, or Network Address Translation. Now, in IPv4, at least for the purposes of our discussion, there's two main types of IP addresses. There are private ones and there are public ones. Now, the private ones are what we use on our LAN, okay? And they are called private because they're not routable on the public internet. Now, the other variety are called the public IP addresses. And they are public because you can route them on the internet. So routers on the internet will accept packets from those IP addresses as a source. But anyway, FreeBSD will get the packet, and it's still sourced from 192.168.1.3, okay, the original IP address here. What we're doing with NAT is changing that source IP address to be 192.168.0.25 in this case, and that's on the WAN. Now, normally our ISP will give us one public IP address. Either they could give us information to put it there statically for our internet connection, or we could get it dynamically over DHCP. But the reason in this discussion why it's a private IP address is in the lab network we're going to use, I already have a firewall in place for my network. So I'm already getting a private IP address from that. So that's why you see private ones for the LAN and the WAN. But the concept of NAT is going to work 100% the same, even when this is in production with a public IPv4 address. So to summarize this, though, we are going to change that source to this source before we send it. Okay? Now go on to the next step. Before we do send it, though, we do have to find out what our best path is to Google.com's IP address. So we look at the destination IP address in the packet the PC2 sent and compare that against entries in our routing table. Basically, they hold the networks that we know about, and it's able to find the best path to use for that destination network. So normally, we either specify a default static route if we're setting it statically, or if you get it dynamically with DHCP, you'll get a default gateway as part of that information. So there will be one main way to send all the other traffic, as long as it's not destined for the 192.168.0.0/24 network, or the 192.168.0.0/20, I'm sorry, 192.168.10/24. But as long as it's not destined for those two, the rest of the traffic will go toward the internet. There's one path in and out of the network. So after we've found the best match, though, then we're just going to select that and send the packet out to the WAN. So that's what FreeBSD does after it gets the packets. And when the packet destined to Google.com's IP address comes back, the source is of course going to be Google's IP address. But in this case, the NAT, the network address translation, is going to actually kind of work in reverse, because the destination IP address will be 192.168.0.25, and part of the state information includes that NAT translation. So we're going to take the original address and we're going to swap the destination of 192.168.0.25 for the destination of 192.168.1.3. And after we do that, then we'll go back and look at the destination address. And then, instead of sending the packet out of the WAN, the best match will actually be the LAN interface, that network that's directly connected. So it's going to send that right back down to the switch, and the switch will send it back to PC2, and we have our communication. So that is how this will be set up, and how FreeBSD will provide routing and firewalling to our network. So again, remember, by firewall I do mean the routing functions as well. I'm using the term as a little bit of overlap just so there's no confusion. But this was part 1 of 3 in our series to configure FreeBSD as a firewall. So with all that, I'm Tyler with T-Tech. I really hope you enjoyed this episode, and I'll see you in part 2. Hello and welcome to this episode of T-Tech. This is part 2 of 3 in our series to configure FreeBSD as a firewall. So in this part, we are going to tweak all the configuration settings and turn all the knobs to make FreeBSD function as a firewall. So to begin with, we're going to run ifconfig, and what I want to talk about is EM0 here. That interface corresponds to our LAN network from our diagram, whereas EM1 corresponds to our WAN. Now, we're going to configure those IP addresses on the interfaces first. We configure these with vi, which is a text editor, and this is in etc rc.conf. Hit enter. And in this file, we're going to go to the last line and just tap O, and that will open a new line underneath it. Now we're in edit mode. We are going to type if config underscore EM0 and equals, and now we're going to have a quote. And this portion we're going to set the IP address. So we're going to do init for an IPv4 address. It's 192.168.1.1 with a net mask of 255.255.255.0. And we want to wrap all this in with quotes as well. Now, the network mask, since IPv4 addresses are represented by 32 bits, so 32 binary bits, so ones and zeros, each octet of this address, so like the 192 is 8 bits, the 168 is another 8 bits. The net mask takes those 32 bits and divides them up into two portions, the network and host. The network portion is much like the street. Okay, the host portion is a lot like the houses on the street. So essentially, the 255 means all the bits are on. So in this case, in the first, second, and third octet, they are all on. So that means we can't change those at all. So what identifies the network portion here is 192.168.1. As long as the first 3 octets are 192.168.1, we are in that network. As soon as we want to go to a network that doesn't start with the same first 3 octets, that's when the firewall gets involved. So that I wanted to explain that so it makes a little more sense of how and why we use the firewall like that. So now we want to configure our WAN interface. We're going to do that with ifconfig underscore EM1. And if you're on a cable modem or DSL modem or any other type of modem you can think of, satellite, fiber, any of them, basically there's 2 ways that we can get an internet connection, either dynamically with DHCP or statically. We're going to show how to get the dynamic one. All we would have to do is type DHCP, and that will automatically get the addressing information for us. But in our case, we had a static address in the diagram, so we're going to go ahead and put that in. So init space 192.168.0.25, and then the net mask of /24. Alright, now on your WAN, when you set a static IP address, you also have to set a default gateway. Now normally with DHCP, that is automatically taken care of for us, but we need to set one here. So default router equals 192.168.0.2 in my case, and then if it was a public IP, it would be whatever public IP they gave you. Now we're going to enable IP routing. To do that, we're going to type gateway underscore enable equals, and then in quotes, type yes as all caps, and that enables it to take that packet and do the destination address lookup and route it. After that, we need to set up PF, which stands for packet filter. That's the firewall in FreeBSD. So we're going to do PF underscore enable equals, then again, capital yes. That enables it. And we're going to do PF underscore rules equals /etc/pf.conf. Alright. Now, a quick side note, so there's no confusion. The PF I'm talking about here is actually an older version of PF from OpenBSD. So PF originated in OpenBSD and then was ported to FreeBSD. But now the two versions of PF have diverged quite significantly between FreeBSD and OpenBSD. So it started in OpenBSD, but then went to FreeBSD. So just so you don't get confused if you're looking up OpenBSD stuff and see references to PF. So now that we've specified our config file where our rule set is, we want to hit escape to get out of edit mode and hit our shift key and tap the Z key twice. That will save our file. And we need to set up the rule set now. So vi/etc pf.conf. And first thing we're going to do is set up some macros. Now, the macros simply hold any kind of information like an interface name or an IP address. We take that and assign that to a macro, and then we can refer to that macro in any rule in our rule set. First one I'm going to type is LAN equals, then in quotes we're going to type EM0, so that corresponds to our LAN interface. And now I'm going to type WAN equals EM1, that corresponds to our WAN, of course. Now down here we're going to set skip on LO0. Now, the LO0 is the loopback interface. It's usually just used for testing, and there's other advanced uses for it, like your router IDs in OSPF. But we're not going to worry about those here. All we have to know for this is the set skip just tells PF to not filter on that interface, so all packets will be let through. Now, we're going to go and set block-policy drop. This tells PF what it should do when it sees drop in a rule. Now, there's two ways it can go about this. There is return and drop. Now, return set basically if a packet comes in and it's destined to a port that doesn't have anything listening on it, or is not open, in other words, is being blocked, it will actually send information back. So, for instance, if it was a TCP packet, we would send a reset acknowledgement back to the sender that sent the packet. The problem with this is that tools like Nmap can use this information that comes back to discern if a port is really closed or open. So if we don't send anything, it doesn't know. So that is why we set that to drop, so when we plug this into the internet and it's getting scanned, those packets won't have any, replies sent to them, and we're exposing less attack surface that way. Now, PF processes packets from top to bottom, and the last rule that matches is the action that PF will take on that packet. Essentially, the packet will come in and it will be evaluated by the rule set, and that block and pass value can be switched on the packet, over and over till the end of the rule set. That does mean, though, that if we put our rules in the wrong order, the packets can inadvertently be dropped. But before we actually get to our rules there, we want to start with that NAT, that network address translation. We want to do NAT on. And we're going to use our $WAN, so our WAN interface is going to do the NAT. And it's going to say from $LAN:network. Now, the cool thing about doing the LAN:network is it maps dynamically to whatever is assigned to EM0 as far as whatever network is. So, if we change the interfaces or the network, we don't have to rewrite our pf.conf file. It just automatically adjusts. Okay. So that has to be going to any destination to match, and then to tell it what source address to use to replace the source address of these packets, we're going to say hyphen have a bracket, space, and then in parentheses, we're going to say $WAN, and then close the parentheses. This allows PF to change the source address to the 192.168.0.25 in our case, when it goes out of the firewall. And the parentheses are great if we use DHCP and the address we lease has changed. So then we don't have to reload the file, it just keeps routing. So now below that, our first rule is going to be block, drop, all. Now if we don't add anything else, the last match rule will always be this block rule. So everything will be dropped. The block drop all does what it says. It's going to block packets from any source address, any destination address, any port, any protocol. Everything is just going to be dropped completely. So, under that though, we're going to pass our LAN traffic in. So we're going to say pass in on our LAN interface, and hopefully we're getting the hang of this, that we're using the macros like this now. So that's going to be in our LAN interface from our LAN network, see, alright, to any destination, and now we're going to keep state. Now the keep state is a crucial concept in PF. By putting keep state there, it tells PF that any packets that match this rule will go into the state, so we know that they belong to that connection. So then when the return packets come back for the connection, PF can just look in its state table instead of having to reevaluate its rule set. And that is actually much quicker than having to send the packet down the rules every time. But that is what the keep state is doing for us, and it's keeping that security. So if it comes back and it's malicious for some reason, or it's not expected, it's going to drop it. And it's going to hit the block drop rule, because it's not going to match this rule. So, now we want to route that traffic out to the internet, so pass out on our WAN from our LAN network to any destination, and again, we want to keep the state. So we're keeping state on both sides of the firewall. Now, lastly, we want to put in a rule to allow the firewall itself to talk. So we can do pings and updates and things like that. So we're going to say pass out on WAN from WAN network to any destination, and keep state for the same reason. So this is how we set up our pfconf to allow the LAN to be able to get into the firewall and route it out to the WAN, and to allow the firewall to talk out to the internet. Now, you will notice there's no pass-in rule for the WAN itself. What that means is the only traffic that will be able to come in on the WAN interface is traffic that matches a state, which is only going to be created for the LAN, at least, if a packet matches the LAN. It's going to create state, then it's going to go out the WAN and create another state, and that will allow that traffic to come back in. But otherwise it will be dropped though if it's not in the state table. So that's the great thing about that. We're going to hit Shift and Z again, double Z to save it again. And now we are going to have to bring up our interfaces at this point. So we're going to do /etc rc.d netif start. Now you could also reboot at this point as well, but that will bring up our interfaces. And you see EM0 has our LAN address, and EM1 has the WAN address. Okay. At this point, we should also always check, make sure the default gateway is set. And as you can see, it is not set, so we do have to go into etcrcd again, routing, start, and that adds our default gateway. Again, you could just reboot, and that would be fine too. We'll do a quick test ping, and we have connectivity. So now we have to install DHCPD, which is the DHCP server that will automatically hand out IP addresses to our LAN side with all our LAN devices on it. So we're going to do package to do that. And we actually, because this is a stock install, we do have to install it the package management tool initially, and after that is installed, we're going to do package update, and this gets the repository information for the installable packages that are available, and that extracts it out so we are able to use them. And after this is done, we'll be able to search through this. So we're going to search with package search ISC-DHCP-server. I'm sorry, actually, just let's do ISC DHCP. There we go. And we want to install the ISC DHCP 44-server. So to do that, we're going to do package install ISC-DHCP 44-server. We'll say yes to it. And now the server is installed. So the first thing I'd recommend doing is actually going back in to etcrc.conf with vi, and we'll go ahead and enable the DHCP server on boot. We want to type DHCPD_enable equals yes in all caps, and save that again with Shift-ZZ. Now we want to actually edit the config file for DHCP a little bit. So we're going to vi user local etc dhcpd.conf. And now, first thing we're going to do is change the domain name. This is the domain name for the local subnet. So what we're going to do is change it to TTEC in this case. Just as long as it's something you know what it is and it's valid in your environment, it will work fine. Now, we're going to change our domain name servers as well. These are what we hand out to clients so they can resolve IP addresses. Resolve domain names into IP addresses. In this case, I'll use 4.2.2.1. And my second one to assign to my clients as a backup will be 4.2.2.2. Now, you can use any valid public ones you want, but those are the ones I'm using here. We'll keep all of the lease times and everything, their defaults. We want to go down here and we'll hit the O key. And now we need to tell the DHCP server what subnet it should listen on. We're going to say subnet. Now this will be our LAN subnet. So 192.168.1.0. And now we're going to do net mask. This should look very familiar from the rc.conf file. So a /24 network mask again. Opening curly brace to start this block. And we're going to enter down twice. And tab in, and we're going to type range. This tells the DHCP server what addresses within this subnet that it's allowed to lease out to clients. Ours will be 192.168.1.100 through 192.168.1.200. End it with a semicolon, and enter down and tab over, and we'll say option routers space 192.168.1.1, and end that with a semicolon. The option routers is specifying the default gateway we're going to give our clients on our LAN side. So this has to be the LAN IP address, okay, of EM0 in our case. So we'll tab down here and wrap all this in another curly brace, and that is our subnet block. So we'll hit escape and Shift-ZZ again. Now before we get ready to reboot this server, we do want to test the file. So we want to use DHCPD-T to do that. And the config file is loaded, the one we just edited, the user local at cdhcpd.conf. And that means it's valid and ready to go. And at this point, if there was an error, it would show you, and you can go in and fix it at that point. Most common error I have done personally is missing semicolons or mistyping an IP address. So be careful about that. But, excuse me. Okay. Now, there's a few more housekeeping things I want to do in the rc.conf file. essentially, I want to enable automatic time, so network time protocol. We're going to use NTP date to do this, and we're going to say enable. So NTP date underscore enable equals yes in all capitals. And we're going to specify what pool of servers we want to use with NTP date underscore flags equals north-america.ntp pool.org in my case. Now, if you need other servers for the country you're in, just go ahead and search NTP pool servers, and you'll be able to find a list from there. Now, last two things we're going to do is sendmail underscore enable equals none. So we want to disable the SMTP server completely. Okay. And we also want to do syslogd underscore flags equals -ss. This disables the UDP port that is for remote logging with syslog. We don't need any remote logging to this system, so it's safe to disable that. Alright, now if you actually want to go ahead and disable those two pieces of software without rebooting, you can just do etc rc.d sendmail stop, and you can do etc rc.d syslogd restart. Okay, and now there should be, oops. Okay, there we go. Now there's no listening port though, so that is what we wanted. So now all we gotta do is quick reboot the server and we'll verify a few things. So I will see you in a second. Okay, welcome back. We're back up and running. So we're gonna log in as root, and we're gonna do ifconfig real quick. EM0, we're gonna want to check the init line. It is the correct IP and mask. Same thing for EM1. Make sure it has the correct IP we configured, and it does in this case. So to check PF, we're gonna do pfctl -sr to show our rules, and all of our rules are loaded, and the syntax we had with $LandColon network and things like that has resolved. Let's check our NAT with pfctl-sn. That's great too. Let's check our connectivity as well with a ping. We're all good there. Let's check that we have a default gateway, and obviously we do. Great. And we'll do sysctl-a, and we're going to pipe that output to the input of grep to search for some text, -i for case insensitivity, and we're going to do forward. And again, net IP forwarding is set to 1 because of the gateway underscore enabled equals yes inside of the etc.rc.conf file. So that verifies our interfaces, PF, and our IP routing. One more thing with PF as well, I recommend though that you verify the config file. So do pfctl -nf and do etc pfconf. And if there's no output, we are all good to go. That just makes sure there's no errors. You'll need that in the future if you're making changes to it and allowing ports and doing port forwards and things. That comes in a lot of handy. So other than that, we'll do one more verification of DHCPD. We're going to run top to do that. And DHCPD is running, and we'll also verify it with netstat-an. And down here, port 67 is running, which is the UDP port for the DHCP server. So this is, with all of that, that is how we set up our firewall in FreeBSD, and we've set it up, the LAN interfaces, the DHCP, the routing, and the firewalling. So with all that, this is part 2 of 3, and I'm Tyler with T-Tech, and I'll see you in part 3, and thank you for viewing. Have a nice day. Hello and welcome to this episode of T-Tech. This is part 3 of 3 in our series to configure FreeBSD as a firewall, and in this part we are going to verify that we have connectivity through the firewall. So first, I have a client booted up here, and it is on the same network as our firewall's LAN interface. So let's see, first of all, if they have gotten their IP address from the DHCP server we set up on the firewall. And this client has 192.168.1.100. So we are great there. Let's look at the client's routing table to make sure it got the right default gateway. Oops. Let's actually make sure we look at the IPv4 routing table. Okay, as you see, it says default 192.168.1.1, and it is out of EM0. So any traffic will go out of EM0 to the default gateway. So that option worked great. Now what we're going to do is ping the gateway's IP address, 192.168.1.1. Before we do, though, we're going to introduce a little bit of a Swiss Army knife of debugging here. We're going to use TCP dump. Now we're going to use TCP dumps -n to not resolve the NS names, and I to select the interface we want to use. And this is from the firewall itself. And we're going to look for EM0, that's what we're going to get the traffic off of. And we're going to filter ICMP because we're dealing with pings in this case. So that starts our log on that. And if we start our pings, let's actually modify this to do TechN2, to only do 2. Whoops. So TechC rather. To do 2 pings, alright. And now we see both of the packet coming from the client to the firewall, and then the firewall here is replying, and then same thing down below. So that does verify that layers 1 through 3 are functioning, and that the firewall is getting the traffic. So other than that, we are going to verify that we can ping past the firewall. So let's ping Google, and we'll also test DNS at this point too, because we have to resolve Google's IP address. So there we go, there's 2 pings, and we're going to examine the output. We have the 192.168.1.100 as the source. It's an ICMP echo request going to 172.278.206, and a little bit later we see an echo reply coming from 172.278.206. So Google replying back to this client, and then that's going to 192.168.1.100. Now, something crucial in understanding completely about how that NAT we set up works is to do that. We're going to look at the WAN side, and I want to show how this address changes, because remember EM0 is the LAN, the 192.168.1.1, but if we look at EM1, that's the 192.168.0.25. So let's look at that with the TCP dump, looking at ICMP while we send those same packets. Oh, look at that. So now we're getting the echo requests coming in, but on EM1, when they're being routed out of EM1, because the default static route, the source is 192.168.0.25, destined to 216.58 to 1678. And then when it comes back, it's destined to what? 192.168.0.25. Alright? That's what I meant about the NAT reversing as it comes back. So that is the beautiful thing there, and that's how the NAT is working. And what will, that is how it's all working out for us. What we'll do now is just do a basic, we'll do an iperf test. So we'll do iperf, we want to download, so we'll -r it, -c, and then we'll do iperf.he.net, and do 300 seconds just so it's easier to demonstrate. And it's connected, and now it's sending traffic. And we actually need to change this filter because that's not ICMP. Now we'll start on EM0. So now you see all the traffic coming through the firewall here, being routed to, from of course 100, 4464 is the port, destined to the creators there, and 5001. Then it's come back from the server, and then the NAT is doing the same thing. It's rewriting those IPs. EM1, just want to drive the point home, regardless if it's ICMP, TCP, UDP, whatever, it is changing this now to 192.168.0.25 and changing the port number as well, but that gets changed back as it reverses the translation. But with all of that, this does verify that we have full connectivity. I just wanted to show that this fully works, and I think a live demo like this really brings this to life and makes it make so much more sense. So again, this was part 3 of 3 in our series to set up to configure FreeBSD as a firewall. So with all of that, I'm Tyler with TTech. I really hope you enjoyed this series, and have a nice day.